Politicians are put there to give you the idea that you have freedom of choice. You don't. You have no choice. You have owners. They own you. Illuminati, you've come to take control.
The trebuchet works. This is the position the trebuchet takes when the counterweight is applied, and the only torques acting on it are the counterweight and the ball, but the counterweight's torque is much greater. The counterweight's torque is much greater than the ball's, so it leans towards the side of the counterweight.
Once we pull the pin here, the counterweight will apply a torque down, and so the longer lever arm, or the part where we have the ball in, will fly up and hit the bar and a bar here and fly off. The ball will still fly out even if there was not a bar there, but it will fly farther because of fat app and tattle.
So the next part that the trebuchet takes is, what we're going to do is we're going to take this pin, pull the left side of the trebuchet down, or the longer side of the lever arm, and we're going to pin it to an extra board that we have sending out of here. So what that's going to do is allow us to keep the counterweight up higher, so that when we release it, it'll apply a torque again. Right now, the counterweight's torque is being counteracted by the pin and the force that it applies on the system.
A trebuchet works by transferring potential energy into kinetic energy. Now while it's loaded, you have this elevated counterweight that obviously has a lot of potential energy and no kinetic energy because it's at rest. The ball is at rest and is at what we call a height of 0, so it has no kinetic energy and no potential energy. Now after you launch the trebuchet, the weight drops and it comes to a stop. So it's at a height of 0, no potential energy, no kinetic energy. Now the ball is being launched very fast, has lots of KE and a little bit of PE, but overall, ME does not change. If you neglect forces such as friction at the pivot point or someone releasing the hook, there are no other non-conservative forces acting on trebuchet.
The counterweight falls, applying a torque on the whole lever to launch it forward with a force of gravity, pulling the counterweight down, making a torque around the pivot point, bringing the lever up to throw the tennis ball.
So in finding the torque applied to any system, you have to find the force perpendicular to the lever arm. Because in a trebuchet you have a hanging counterweight, the force is not always at the same angle relative to the lever. That's why you need calculus, which is why we have the cinder rule up here. This accounts for the changing theta that we have. And so we use the equation for torque from 0 to 71.8 radians, because that is the change in the theta experienced by the weight. And that gives us this for our total torque, the 41.56. From there we move to torque equals I alpha, and I equals mr squared. We're treating the tennis ball as a point mass, so we use the mass of the tennis ball and the radius of the larger arm to find our I. Then we can solve for alpha because we have torque and I. We find our alpha to be 685.31 radians per second squared. So now we have our angular acceleration here. We know our theta, the change in the angle that the tennis ball experiences on the other end of the trebuchet. What we don't know is the angular velocity at launch point, and we know that the initial angular velocity is 0. So we use this equation up here, which I'm not plugging our numbers, and we get to omega equals 51.02 radians per second. That's how fast the tennis ball is changing angles. We can relate that to tangential velocity, and we find out that at launch, the tennis ball is moving at a speed of 55.73 meters per second.
In order for you to get a good idea of how the trebuchet is loaded and how it fires, I turn the camera around so you can see me loading this. First, the arm is cocked back. The pin is inserted through 2 holes, one in the base, one in the arm. The catapult is loaded. I take this cord here, and pull, and it fires.
Alright, yep.
So these idiots broke the trebuchet. Yeah, we fixed it. Now we're putting back more weights back on it because it's broken. Yeah.
Damn, son, where'd you find this?